start recording. And then I'll share my screen. There we go. So here's the last problem that I have in our notes, which is we were taking 5/4 and 7/2, and we were converting them because they are improper fractions. All right, the numerator is larger than the denominator. And we were converting them into into a mixed fraction. And the method on how to do that is just the division. That's it. The hardest part was just realizing where everything goes. So let me just do another example here. All right, so we're going to do 12 over, oh, sorry, wrong color. So let's convert 12/5 to a mixed fraction. Okay, so real quick, let me label things here. So with 12/5, the top is called the dividend, and it's also called a numerator. The 5 would be your divisor, and that's also called a denominator. And when you are doing long division, your divisor goes outside, and your dividend goes inside the house. So that's how we set this up. So in other words, okay, our denominator goes outside, and our numerator goes inside. Okay? Now, for us, we're going to get 5 divides into 12. That's how we read that. 5 divides into 12. All right. So now all you do is ask yourself, how many times does 5 go into 12? Somebody?
Yeah.
Good. So I'm going to put a 10 underneath and just subtract. 12 minus 10 is 2. Now, we need to go ahead and start labeling all this stuff. Okay? So your quotient is going to be the whole number. Your divisor is still your denominator. That didn't change. Your remainder is your numerator. So in red on the right-hand side of the screen, 12/5 is equal to 2 2/5 as a mixed number. All right, does that make sense, everyone? Okay. How are we looking so far? Pretty good? All right, so that's just a review. So now we're going to go the exact opposite way. Okay? I'm going to give you a mixed number, and what I want you to do is make an improper fraction. Now, if you've been following along here, especially with this example, you're going to notice that basically there's like a little formula here, and it's just a matter of where you put things. Okay? Just a matter of where you put things. So now what we're going to do is we're going to convert 2 2/5 to an improper fraction. In other words, we already know the answer. The answer to this problem is 12/5. Like, you know that. You can see it. Now the question becomes, all right, how do we get there? Okay? Well, here's how you do it. Our 5 we know is our denominator. Our 2 is the whole number. or the big number out front. And then we have our numerator. So to convert, your denominator stays the same. And then up top, you take your whole number times your numerator. I'm sorry. Hold on. Wrong one. Whole number times your denominator, and you add your numerator. And that is the thing that you got to like memorize, I guess. You're never going to hear me say memorize too much. But that's what you got to know. Right there. Okay? So if you just follow the trend, if you just follow that little model right there, 2 2/5, well, the denominator stays the same. That's going to be a 5. Now, up top, I'm going to write my whole number times my denominator and add my numerator. 2 times 5 is 10. And 10 plus 2 is 12. And that's how you do it. It is as simple as that. Does that make sense, everyone?
Yes.
All right, let's try. Let me give you one to do. 1 3/8. Please convert that to a improper fraction.
Do you want the answer?
Sure, I'd love an answer, Kim.
11/8.
11/8. All right, let's see if you're correct. So according to my model up top in the upper right-hand corner, denominator stays the same. And then I have in a numerator 1 times 8 plus 3. 1 times 8 is 8. And 8 plus 3 is 11. So 11/8. Kim, excellent job. I see all 15 of your alarms work today. Oh, no, that's your husband that does all the alarms, right?
No, he's the responsible one. I'm the alarm setter.
Yeah. No, the other day, you're right. The other day I did say I just woke up. But I was up super early that day. And I got jobs. As soon as I wake up, I have work to do. I got to clean. I got to take the dog out, and I got to feed 2 cats. And they get special food in the morning. So I'm already working. Then I usually just lay back down. All right. So we're going to change gears now. Okay, we're going to change gears. We are going to go back to chapter 2, section 5. All right? Because we need this technique. This technique is going to help us to multiply, divide, add, and subtract fractions. Okay? So chapter 2, section 5 is very simple. It is called prime factorization. All right, how many of us have ever heard of prime factorization before? All right. So when you hear the words prime factorization, then what do you think? Yeah. Good. No, I mean good in a good way. All right. Math is, you got to know the definitions. You got to learn these words. Okay.
Factoring prime numbers.
Kim, you're absolutely correct. That's exactly what it is. It's factoring prime numbers. Now let's think about what you just said. Okay. First, when we say factor, what do we mean? Because Kim, what you said was factoring prime numbers.
Like distributing or like organizing.
Okay. All right. If we were organizing, I don't think I'd use a fancy word like factorization, but you're on the right path. When we hear the word factor, does anything ring a bell? It's okay. If the answer is no, that is fine.
Sounds like division.
Sounds like
Multiplication.
yes. There you go. Lakendra nailed it. All right. Factor means multiplication. And the numbers that we are talking about are these numbers called prime numbers. And they are special numbers, okay? So, what makes a prime number so special? Prime numbers are numbers whose factors are 1 and the number itself. All right, let me zoom out here a little bit because I'm going to write one more sentence. If a number is not prime, then we say it is composite. Okay? All right, now, from here until you no longer have to explain math or talk about math with anybody. So basically until you're dead. When you see the word factors, you need to be thinking multiplication. All right? I am definitely teaching MAT080 courses next semester. So if you like my vibe, definitely sign up as soon as you can. Because I'll be honest, my classes fill up like within the first week. Okay? And because we are still following CDC guidelines, stuff like that, they don't allow people just to come into class. Like, it's really hard for me to add somebody else. All right, so once I get my finalized schedule, I'll let you know. But I think I'm teaching. I'll tell you in a second here. John, here I am. I'm teaching math. Oh, I got times. These are tentative. They could change. MAT080 Zoom, just like we are right now. Tuesdays and Thursdays, 9 to 10:40, and then from 10:45 to 12:25 p.m. So that's what I'm doing 90 next semester. All right, so from now until you're done, when you see the word factor, you need to be thinking things that are being multiplied. All right? Doesn't have to be numbers, but we're thinking multiplication. Now, prime numbers are very special because the only two numbers that I can multiply to get that is 1 and the number itself. If there are more factors, then we say that the number is composite. So here are some prime numbers. And these are just the first couple. These are, I'll be honest with you, for us, these are like the heavy hitters here. Okay, these are the heavy hitters. Now, do not automatically assume that prime numbers are odd, because the very first prime number is even. So that completely just blows up your argument. And 1 is not prime. So don't worry about 1. Now, if you think about what is on the board here, the only two numbers that I can multiply to give me 2 are 1 times 2. Same thing with 3, 1 times 3. Same thing with 5, 1 times 5. 4, well, I can rewrite 4 as 1 times 4 and 2 times 2. Because I have 2 options here, we say that's composite. Does that make sense so far? Okay. Now, here's what's beautiful about prime numbers, okay? You can take every single number that exists and you can break it down into its prime number factorization. In other words, we can rewrite any number as the product of primes. And every single number has a different product of primes. In other words, numbers have fingerprints. We can figure that out. All right? The stars up in the sky. Every single star is a little bit different. They all have their own fingerprint. Snowflakes have their own fingerprint. You have your own fingerprint. Now, let me show you how we find this fingerprint for our numbers. So here's the number 12, and here are the directions. Find its prime factorization. So as soon as you, like I said, as soon as you see prime factorization, you need to be thinking multiplication of prime numbers. Multiplication of prime numbers. So it doesn't matter what you pick. All you need to find are two numbers that multiply to give you 12. So I'm going to use 3 and 4. Yeah, LaKendra, I like 3 and 4. I agree with you. Now, if you notice, 3 is prime. So what I'm going to do is give this a little circle. However, 4 is composite. So I'm going to break that down a little further. Two numbers that multiply to give you 4, 2 and 2. Notice I didn't choose 1 times 4 because that doesn't change anything. All right? So now I got 2 times 2, and 2 times 2 is prime. And here's our prime factorization right here. 12 equals 2 times 2 times 4. Oh, sorry. Whoa. 2 times 2 times 3. Sorry, I got a little ahead of myself there. All right? Now, let's do another one. Let's do 36. Okay? So with 36, I'm going to break this down. I don't care what two numbers you give me. Just give me two numbers. Two numbers that multiply to give you 36.
12 and 3.
12 and 3. 3 is prime, so let's break this down a little further. 12, well, we just did 12, so we could just copy what we have. So this is going to be 3 and 4. And then 2 and 2. So 36 equals 2 times 2 times 3 times 3. Are we all on the same page still? Did I lose anybody along the way? Yes or no? All right. Now, at the very beginning of chapter 4, we talked about fractions. And we talked about, how do we represent fractions? And we can represent a fraction like 1/2 as just a big rectangle where you have one of the two squares shaded, right? Am I right? Okay. If I wanted to, I can write the fraction 2 over 2, which means now I have two of those little squares or rectangles shaded. And what does 2 over 2 equal?
1.
Yeah, I agree. Stevie. 2 over 2 equals 1. Because remember, a fraction is a part divided by its whole. Well, if the part and the whole are the same number, then you just have 1. Does that make sense, everybody? So now you may be sitting there asking yourself, all right, well, how is he going to relate this prime factorization to fractions? Here's how. If I gave you the fraction 12 over 36, and I asked you to simplify it, there are many ways to do this. Some of us may be sitting there going, well, they're both even, divide them by 2. I don't care about that. We'll worry about that later. All right? Here's what I'm going to do, and watch what I do here. I'm going to rewrite 12 as 2 times 2 times 3. It's prime factorization. I'm going to rewrite 36 as 2 times 2 times 3 times 3. Does that make sense, everyone? Now, do you notice anything that is the same in the top and the bottom? Yes or no? Yeah, how about right here? 2 over 2. What does 2 over 2 equal?
1.
1. Very good. So put a 1 there. What about right here? What's 2 over 2 equal?
Just 1.
Very good. So I can put a 1 there. What about right here? What's 3 over 3 equal?
It would be 1.
That would be a 1 also. So it looks like after I do what we call simplifying, I'm left over with 1 times 1 times 1, or just 1 in the numerator. And what's left over in my denominator?
The 3.
So, if I give you the fraction 12 over 36 and I ask you to simplify it, it simplifies down into 1/3. And notice the technique that we use to do that is called prime factorization. Now you can see when you're done because you won't be able to cross things out anymore. Does that make sense? Is that a little bit easier than what you were taught before, which is, well, you just keep doing it until you stop? It's like, well, sometimes I don't know when to stop. All right? Are there any questions here? All right. So what we're going to do is we're done with this section 2.5 or 2.4. 2.4, 2.5. We're done with those two sections. Now we're going to go back into chapter 4. See, that's why I didn't go over this in chapter 2. Because it was like, if I would have showed you in chapter 2, then we went to chapter 3. It's like you got a whole chapter where you didn't do this stuff. So I was like, I'll just do it later. All right? So now the question becomes this, okay? Oh, hold on. Got to go back here. All right. Here's what I'd like you to do. I'm going to simplify the following fractions, okay? They're not difficult. 10 over 15. Let's do 10 over 15. 3 over 21. And I want to give you one more. How about 64 over 200. All right? So 2 easy ones, 1 difficult. So I'll wait a minute. Go ahead. And please, try the prime factorization method. Okay? Because that's the way I'm going to do it. Okay, are we ready? Like I said, I think the first two are pretty easy. The last one, it's going to take you some time. So with this first one, all right, let's break it down into its prime factorizations first. So if you just want to watch, that's fine with me. What I'm going to do on the right-hand side, I'm going to write 10 and do two little lines underneath. This is called the prime factorization tree method. It's called the tree method because it kind of looks like you're making branches. Two numbers that multiply to get 10, 2 and 5, they're both prime. Now, 15 is going to be 3 times 5, and they're both prime. So now I take a deep breath, and I look for numbers that are the same in the numerator and denominator because I know when I simplify it, they equal 1. So I have a 5 in the numerator, 5 in the denominator. There's nothing else. So the answer is 2 over 3. Now I'm going to do 3 over 21. Well, 3 is prime. I don't have to worry about that. 21 is 3 times 7. So now I look in the numerator and denominator. I have a 3 at top and a 3 in the bottom. I know that turns into a 1. And there's also something that's happening here. If you cross everything out, regardless if it's in the numerator or denominator, just put a little 1. Because there's still something there. It's a 1. So this turns out to be 1 over 7. How are we looking so far? All right. Now the last one, 64 over 200. This one, we got to do some work. So 64 is 8 times 8. 8 and 8 are both composite, so I got to break it down even further. 2 and 4. 2 and 4. The 2's are prime. So now I got it all breaking down. So let's see here. 1, 2, 3. I have 6 2's. 1, 2, 3, 4, 5, and 6. All over 200. Now 200, I need to break that down. How about 20 times 10? Does that work? 20 times 10 is not 200? Kim, you shook your head no. Am I wrong? Isn't 20 times 10 200?
No, you're right, but I think it needs to be reduced
Well,
more.
yeah. No, it is. My dog is going crazy. No, it is. I'm just saying, is 20 times 10 200? So let's break it down. How about 20? I use 10 and 2. And then 10, I'll use 2 and 5. So let me circle my primes. 10 is 2 and 5. So I have 1, 2, 3 2's and 2 5's. All right. How are we looking so far? Good? Now all I do, look for the same number at top and bottom. 2 over 2, 2 over 2, 2 over 2. Since there's nothing else I can do, I multiply what's ever remaining. 2 times 2 times 2 is 8. 5 times 5 is 25. And I know I'm done. Does that make sense, everyone? How many of us were never shown this method on simplifying fractions?
I wasn't.
You, Lakendra wasn't. Tasia raised a hand. Crystal, were you ever shown this?
No, I don't think so.
Does this help? Is this easier than what you remember?
Yes.
All right, well, let's get more complicated. So now we have negative 120x to the second divided by 192x. Now, here's the best part about this. Your process doesn't change. Now, what do we see about this problem that kind of annoys us? Yeah, I agree. The negative, what else?
The x squared.
Yeah, the x squared thing, right? But here's the thing. do you know what x squared means? Like, do we know what x squared means?
It's x 2 times, so.
All right, so
really, when you write it out, one of the x's are going to cancel out each other, so there'll only be one x left.
all right, so Kim, here's a problem you've never seen before, and you already got a really good game plan on how to do that.
This is like the only thing I remember from school, from class in high school.
So Kim is right. And I think it was Lakendra who gave us what x to the second means. So what we're going to do is we're going to write x times x. That's x to the second. And then we know when we simplify, we are looking for things that are the same on the top and bottom. So since I have an x in the numerator and an x in the denominator, I know they're going to simplify. The hardest part about this problem is the 120 over 192, because you actually have to figure that out. So let's go ahead and let's do that. So I'm going to break down 120. How about 12 and 10? Then I'll break the 10 down. That's fast. 12 is going to be 2 and 6. And then 2 and 3. So 120 is going to be, and I like to write them in order, 2 times 2 times 2 times 3 times 5 with 2 x's. How's that so far, everyone? Pretty good? Okay. Now we're going to do 192. And two numbers to give you 192. 2 times 96. Oh, I hear a baby.
Oh
Is that you, Stevie?
Yeah, I muted it somehow.
That's okay. So 2 and 96. Now we can break down that 96 even further. So 96 divided by 2 is 48. So 2 times 48. (48) is 4 times 12. Which that can be broken down into 2 times 2. 12 is going to be 2 times 6. And 2 times 3. Like I said, every single number has their own fingerprint. There are no other prime factorizations out there like 192. To me, that's unbelievable. Because a lot of times we think of numbers just being numbers. But now it's like they actually have like characteristics about them. So let's go ahead. Let's write this out. Oh, this is going to stink. 1, 2, 3, 4, 5, 6 2s and a 3. 1, 2, 3, 4, 5, 6. And a 3 with an X. Are we all on the same page so far? Okay, so from here, same top and bottom. So there's 2 over 2, 2 over 2, 2 over 2. I have a 3 over 3, and an X over X. So all those they all simplify. What's left over in the numerator? And be careful. 5x. What's left over in the denominator?
8.
And what about that negative sign?
Up front.
Perfect. So that negative sign that we were concerned with, it just came along for the ride. That was it. The hard part I think about this problem was literally breaking down 120 and breaking down 192. That was the hard part. How are we looking? All right, simplifying fractions is very simple. Now, you may have heard of this, what I'm about to say, in the past. Divisibility rules. Anybody ever hear those two words, divisibility rules? And I can't even say it. Divisibility rules help us to find factors. For example, if the number is even, you can always divide it by 2. Okay? So I'm going to write out a couple divisibility rules because they help us with this. Like this whole 192. Like, how did I know 2 works? Well, because 192 is even. So I know I can divide it by 2. So let me write out a couple divisibility rules. Your book has a bunch more. I only use the first three, and I only use them to help me break things down. My whole thing about simplifying fractions, I want to see when I'm done. I don't want to have to worry about, well, does this go any further? So here's our divisibility rules. These are the only three that I'm going to show you. If the number is even, you can always divide it by 2. Okay? The next divisibility rule. If the sum of the digits in the number is divisible by 3, then the number itself is divisible by 3. All right, so let me give you an example of that one, okay? $12. Now, 12 is even, so we know I can definitely divide it by 2. But if you look at 12 and you took the numbers and you added them together, so if I add the digits, 1 plus 2 is 3. Since 3 is divisible by 3, so is 12, okay? Another one would be like, example would be like 48. If you look at 48, 4 plus 8 is 12, and 12 is divisible by 3, therefore 48 is also divisible by 3. All right, does that make sense? So that's how we check to see if a number works with 3. And then the last one, I think everybody knows this one. If the number ends in a 0 or 5, the number is divisible by 5, which means you can always divide it by 5. These 3 rules just help us to break something down. You okay there, buddy? Been running around all morning. All right. So here comes the big thing of the day. All right, there were 2 big things. This is the second. The first was learning how to simplify a fraction, prime factorization method. And that prime factorization thing is unbelievably important. All right. Now we're going to learn how to multiply or divide fractions. Adding, subtracting fractions is actually more difficult, so we teach that second. All right? So the first thing I'm going to do is just focus on multiplying. And here's how you do it. A. Simplify all fractions. B. Multiply the leftovers from left to right. That's it. It's as hard as it gets. Let's not make this too difficult. You always, always, always simplify your fractions before you multiply them. Now, I know a lot of us were never taught that. But then again, you didn't have me as your teacher. All right? So, you're going to multiply, to multiply, you simplify the fractions first. Then, you're going to multiply all the leftovers from left to right. So, here's an easy one. 1/2 times 1/3. Now, what I like to do is this. How about everybody just watch? Just watch. I'll give you a minute to write this down because this problem is super easy. I start in the upper left-hand corner. I start in the first fraction's numerator. That's a 1. I can't reduce that any further. So I move on. I look at the 2. That's prime. I can't reduce that any further. Then I move over to the next fraction. I look in the numerator. That's a 1. Can't do anything there. I look at its denominator. It's a 3. Can't do anything there. So step 1 of simplify all fractions is already done. Now I'm just going to multiply from left to right. 1 times 1 is 1. 2 times 3 is 6. So 1/2 times 1/3 is 1/6. You literally just go left to right. Okay? Now, let me show you an example of where we got to simplify a little bit. Five eighths times 4 sevenths. Now, like I said, just watch. I'll let you write this down. All right, I'll give you a minute. So here's what I'm going to do. Back in the day, a lot of us would have taken 5 times 4, which is 20, and then 8 times 7, which is 56. And then you'd have to break down 20 over 56. And you could totally do that. But you're creating more work for yourself. Because if you think about it, writing the prime factorizations of 20 and 56, they can get rather large. So watch what I do. First fraction, numerator is a 5. Can't do anything there, so I leave it alone. So I'm just going to rewrite it. Now that 8 I can break down. 2 times 2 times 2. Okay? Now, second fraction. The 4, well, that's going to be 2 times 2. And that 7 doesn't simplify. It's prime, so I leave it as a 7. Now, once you get better at this, you can go directly from here into the answer, but I'm going to do something here. I'm going to take my entire numerator and just put it in order. Remember the commutative property of multiplication from chapter 1. It doesn't matter the order in which you multiply because you're multiplying. So I put 2 times 2 times 5 in my denominator, 2 times 2 times 7, and now I look for numbers that are the same on top and bottom. That's it. So my answer is 5 over 14. Does everybody see how I did that? Notice I simplified first and then I multiplied. Now, just to demonstrate, let's say you did it the old school way. You did 5 times 4, which is 20. And you did 8 times 7, which is 56. All right? You would have to break down 20. And the prime factorization of 20 is 2 times 2 times 5. Then you'd have to break down 56. So 56 is it's 8 times 7. So that's going to be 2 times 2 times 2 times 7. Boy, isn't that interesting? If I multiply the numbers and then do their prime factorization, notice I get the same exact thing here. So why not just simplify first when the numbers are small? Because it's easier. It's faster. Then apply your n over n rule, like 2 over 2 is 1, 3 over 3 is 1. Just cross them out and you get your answer, 5 over 14. And here's the best part, Kim. You don't have to ask yourself, can 5 over 14 be reduced? And the reason, or the answer to that question is, you already simplified everything right there. Are there any questions? Did we ever think multiplying fractions would be this easy? Because it is. And I know fractions are that thing, it's like, oh, I see fractions, I'm done. Not anymore. Not anymore. It's easy. This is child's play. You should be angry at me now. Because you should be like, man, this is easy, floater. And I'm going to be like, yes, I know. All right? So, while I was blabbering there, did we write this down? All right, because we're gonna do some more examples here. And you're gonna see just how easy this is. All right? So let's do another example. Negative 9 over 20 times negative 5 over 12. All right? So let's get the awkward thing out of the way. You have two numbers, and they're both negative, and you're multiplying. What's a negative times a negative? Positive. So you know your answer's positive. So those two negative signs you don't have to worry about. They're done. You know the answer's positive. Now, let's break down. No, excuse me, 9 is 3 times 3. 20 is going to be 4 times 5. And that can be broken down into 2 times 2. So 2 times 2 times 5. Now, for the second fraction, 5 doesn't change. That's prime. However, that 12 is 2 times 6 and 2 times 3. So it's going to be 2 times 2 times 3. Now, this is just me. I'm going to rewrite this the way it looks so that my numerator is all in order. 3 times 3 times 5. And I'm going to do the same to the denominator. So it looks like I have 1, 2, 3, 4. 4 2s, a 3, and a 5. Does that make sense, everyone? Am I moving too fast? Am I moving too fast? Are we okay? All right. Look for numbers that are the same in the top and bottom. So I definitely have a 3 in the top and 1 3 in the bottom. I definitely have a 5 in the top and a 5 in the bottom. And that looks like about it. So I'm left over with a 3 in the numerator. And then 2 times 2 is 4. So 2 times 2 times 2 times 2 is actually going to be 16. So the answer is 3 over 16. How are we looking? Easy stuff? Easy? All right. I hope it is. I hope it is. All right? Because like I said, I know we hate multiplying fractions. And I'm going to be honest with you. Maybe you were just never shown an easy way to do it. Maybe you just weren't shown.
We were always taught to multiply everything and then simplify, which I hate that because it's too big of numbers.
Dumb! It's the dumb way to do it. All right? Sorry, I'm being a little abrasive there. It's not dumb. If you want to do it that way, that is absolutely fine by me. But just realize, just like Stevie said, the numbers get large. And then you got to simplify everything. Why not just simplify first? Okay? Are there any questions? All right. So let's do a couple more. How about 1/8 times 72? Ooh. This is one we've never seen before. I mean, you got a fraction times a whole number. All right, but here's one of these things about whole numbers. You can make any whole number a fraction you want. All you have to do is put the number 1 underneath it. Now you got a fraction times a fraction. Okay? Now you got a fraction times a fraction. So, watch this. Just watch the screen real fast. That 1/8, I'm going to leave the same. Isn't 72 8 times 9? Now, did I break these down all the way into their prime factorizations? Yes or no? No, I didn't. Stevie, I see you shaking your head no, and I agree. Here's why. Once you get really good at this, you'll start to see things. For example, I see that 8 in the denominator. So let me highlight what I'm talking about. I see this 8 in the denominator. And then I see that 72, and I sit there and go to myself, well, I know 72 is 8 times 9, which means those two will end up reducing themselves. They turn into a number 1. So if I were to put this in numerical order, 8 times 9 over 8, notice the 8's reduce. I'm left over with a 9. If you were to break this all the way down into its prime factorization, remember 8 is 2 times 2 times 2. 9 is 3 times 3. And then you were to put them in order. 1, 2, 3 2s and 2 3s. And you reduce. You still get that 3 over 3, which is equal to 9. What I mean is, you could save yourself a little bit of pain and anguish if you see that you have multiples of other numbers floating around. All right? But if you don't see that, just break everything down. It takes an additional 5 seconds. I don't know about you. I'd rather take the extra 30 seconds to do a problem and get it right than not take the extra 30 seconds, do the problem, click on submit answer, then it says it's wrong, and now I got to do it all over again. So it takes me another minute and a half, 2 minutes to do this problem. When if you just slowed down, you'd have been fine from the start. Does that make sense, everyone? Yes or no? All right. So we have one more thing to do in this chapter, or in this section, dividing fractions. I'm going to save that for Friday. Okay, I'm going to save that for Friday because I'm going to be honest with you. I think we did a lot today.